The power of locality-sensitive hashing is closely related to the behavior of this particular function, 1 minus something to the power k, which is then raised to the power b, and then again subtracted from 1. This particular function, as you can see, is a very steep one, with the result that this particular value pq, which is nothing but the probability of a match in one of the locality sensitive functions f, is amplified. So even if this value pq is fairly moderate, say something close to 0.1 or 0.15, it really becomes amplified to a very large value, giving a very high probability of match. At the same time, the false match probability is driven to 0 as long as it is a little smaller, say 0.07, fairly close to something like 0.15, but it gets driven to a very small value as long as it's reasonably smaller than pq. The place where this steep rise happens depends on the choices of k and b, and by suitably adjusting it, these parameters depending on our values of p and pq, we can get the required behavior that we want to achieve. LSH has many important applications which fall under the big data category these days. For example, when you have hundreds of millions of tweets, how do we group similar tweets without having to compare all of the pairs, which is an impossible task, but since there are n squared pairs, and if n is in the hundreds of millions, it just becomes impossible. So LSH is one way out. In enterprise search, we saw the problem of finding near duplicates or versions of the same root document. This is another problem which can be addressed using LSH. Finding patterns in time series from sensors where you have multiple sensors capturing many different parameters, such as from a car or from a piece of machinery or from a ship, and you want to find patterns in that time series, then LSH-like concepts turn out to be useful there as well. Another example, which is also discussed in the Alman Rajaraman book, is the resolving identities of people from different databases or multiple inputs. An example of such a problem is one is described in the book, resolving databases from different systems. Other example is figuring out which Twitter IDs match which Facebook IDs and which LinkedIn IDs and which email IDs. Now, this is private information which people want to keep separate, but there are many companies which are engaged in figuring out, using concepts like LSH, which identities actually should be clubbed together and are very likely to be from the same person.